Good morning, everyone. Today we're going to continue our discussion on multiple linear regression. Okay, so the packages that we installed last time were MAS, dplyr, ggplot, car, caret, glmnet, and lmtest. So I specified here the main purpose of those packages. We used the Boston data, and it came from the MAS package. So let's load first. Just make sure you have loaded already the packages. So we used Pacman, which we can use for a one-step installation and loading process. Okay. So once you have installed these packages and loaded it, we use the Boston data set. Okay, let's have a quick review of what this data set is. Okay, we can okay, maybe go to the packages and go to MAS. Can go directly to MAS. Okay, and click this. And then here are the functions that are available in MAS, including the data set. This one, Boston. If I click this, so it gives us the details about the data. Crime is per capita crime. This is the crime rate in that town in Boston. Zone, proportion of residential land zone for lots over 25,000 square foot. Indus, proportion. So these are numerical variables. Proportion is a ratio of non-retail business acres per town. Chas is Charles River. It's a dummy variable. Okay, I'll explain what a dummy variable is. Is equal to 1 if tracts if tract or the land bounds the river. So if the land bounds the Charles River, then it's 1. Otherwise, it's 0, which means it could be internal, in an internal town. Interior, not internal, interior. And the one that bounds the Charles River is equal to 1. There could be a reason for that because we're looking here at the median value of homes, okay, in thousands of dollars. So it's possible that if it bounds the river, then it could be expensive or cheaper depending on what our model tells us. NOx is nitrogen oxide. This is more on pollution. Okay, so if an area is polluted, then it will have a high concentration of NOx. Average number of rooms per dwelling. Proportion of age owner-occupied units built prior to 1940. Okay, then distance from 5 to 5 Boston employment centers. So if the distance is low, then that could mean that the median value is high because proximity to employment centers could raise the value of the house. Okay, and then index radial highways, proximity, also tax rate, etc. Okay, so what we're interested in is to model the median value of the house. Okay, so let's load that class. How do you load a data? Well, we use the function data, and then make sure that the package from where the data is coming from is already loaded. So I showed you that here, MAS is already checked. Okay, so we can now access the data Boston. We ran this last time class, right? So when you run this class, it will automatically be reflected here under values, first values. And then when you click this, okay, 506 observations. Let's print it. So clicking this class, clicking this icon here, spreadsheet icon, is equivalent to viewing it. And then, so here we have a view of the data. A view of the data class here. No? There are 506 observations, 506 rows there. And then 14 total columns, okay, 14 variables all in all. 1, 2, 3, 4, 5, sorry, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14. Okay, so as we said, multiple linear regression allows us to model or to explain, create a model, mathematical model of a variable of our interest, in this case, the median value of the house. So we'd like to create a model where we can predict, okay, the median value of the houses here in Boston. Okay, so we go back here. Okay, we can let's create a new object df because Boston is quite long. I'm just using a of course you can still use Boston. If I create this class, you notice that there's another object here, df, and it's exactly the same as Boston. Okay, we're doing this in order to shorten the name. All right, then we did this already. View means we'll generate a printout here. Okay, so we can see the values class, our data. Okay, and then what else is important? Structure class. I don't think we were able to discuss this last time. Let's see structure class, strdf. Okay, what does that give us, class? Take a look at this. It gives us metadata. Metadata means data about the data. So it's information about the data. It's a data frame class. So this data, Boston, is a data frame, and you notice that it's under data. If it's a vector, then it should be under values. Okay, so we can see here that it's a data, and from the structure function, we have here 506 observations of 14 variables, and it lists down here the variables. Now take note of this class, $CRIM. What does a dollar mean, class? It means that you can only access this variable CRIM, which is the crime rate, through the data frame df. The data frame that we're looking at is df. Okay, so by way of example, if I want to get, let's say, I want to get the mean, the average, so the mean of CRIM. Okay, can you please try, class? What's the average of CRIM? In the chat box, please. What is the average of CRIM? Attendance, mamaya na lang. Average of CRIM, class. Waiting for your response. Type nyo sa console or anywhere in your source window. And nag-error. Okay, Jerry Lane, nag-error. How about the others? Nag-error ba? Bakit error, class? Waiting for the others to give their answer, class. Get the average of the variable CRIM. Hello, class. That's a very simple task, class. Error din, Adrian. Okay, how about the others? The others, please answer also, class. Okay, John, error. Only 3 tried. Okay, James, thank you. Medyo mabagal yung ano natin, response rate, no? You're 26. So far, apat pa lang class yung nag-respond. And it's quite, I hope you can respond quicker class, please. Why is it taking so long? Just try class kung nag-error o hindi, no? Kung ano yung sumagot na ano. Okay? Pero why are you taking so long, class? Simple lang naman, tatype nyo lang yung mean crime, no? And hindi pa lahat nag-respond. Okay, so you'll get an error, class, no? Why? It's an error because R does not recognize CRIM. Okay, if you take a look at your objects here, wala namang CRIM dito, di ba? Nasa global environment natin. There's no such thing as CRIM, class. So R does not recognize that. So as I was saying a while ago, you can only access these variables under df by accessing df, class. So mean, okay, you have to use df, class, and then dollar, okay. df, which is our data frame, and then dollar, then you're able now to access all the elements that are under df. Okay, so CRIM, for example, control enter, there. Okay, we were able to get that median df, dollar, what else? Let's say NOx, maybe, NOx, 0.538, that's the middle value. Okay, so you can only get this, access these variables through df. Now, if you want, class, is it possible to get the mean of CRIM without accessing df? Yes, it's possible, class. You have to attach. You use attach. Okay, so let me do this. Attach Boston. Anyway, it's the same. Attach Boston. Control enter. Oops, sorry. Nag-summary. No? Erase ko lang, class, sandali, ha. So what did I do, class? Attach Boston. Attach Boston. Okay, now what happens, control enter, when I attach Boston? What happens when I attach Boston? When I attach Boston, class, it means that any code that I'm going to write from here, from this point, will be using Boston as the object. So let's say mean of CRIM. Okay, notice that it comes out, class. Mean of CRIM, control enter. Why does it solve it now, 3.6? Because I attach Boston, and attaching Boston signals to R that any code that I'm writing refers to Boston. So that's why I did not need to write Boston dollar CRIM. Okay, median, let's say another one, median. And then let's see, let's get the NOx again, NOx. So will this work? Yes, it will work, because getting the median of NOx will mean that I'm using the Boston data set. There you go. Okay, and standard deviation, maybe the standard deviation of distance. Okay, this will work again. Okay, all right. Okay, so everything that I write will always refer to Boston. So if I'm going to use another data frame, I have to make sure that I detach Boston, because otherwise that there could be a problem. So I'm going to detach Boston now. Detach Boston. Detaching Boston will mean that you're not going to use Boston now for the next codes. So detach Boston, and once again, when I get the mean of CRIM, okay, mean of CRIM, Oops, wait Dinitouch ko na si Boston. Wait. Mean of cream. Wait, let me see. Detach again. Detach. Boston. Okay, so nag-detach na siya. So dapat this should not work anymore. Okay. Mean of NOx. Okay, nag-error na class. So apparently class, when I run this, hindi siya nag-run talaga, no? Yung detach Boston. Okay, so that's what's most important class with the dollar sign here. So you can only access the dollar sign through the data frame that you're using. Okay. If you're using many data class, it might not be a good idea to attach unless in the next steps that you're running the data, you're going to just to use focus using on on that particular data set. All right. So any questions about that class? The concept of the dollar sign, the use of the dollar sign in accessing the variables in a particular data. May I have your confirmation, please, if that's clear? Okay, thank you. Again, baka pa pwede class na ano, is it possible to, yan, thank you, yan, thank you, to respond faster class so that we don't waste time. Okay, good. Thank you so much, class. Thank you so much for your participation. Okay, now let's proceed, class. There's another function called summary. And the summary function is, we have used this before. Remember summary car, summary pressure. It gives us the 6-number summary of a variable. Okay, by the way, class, before we go to summary, let me just show to you here. Okay, CRIM is numeric, class. So this is a numeric variable. So these are the values. Zone is also numeric. Industry is numeric. Now take a look at this one. Chas is integer, so 0, 1, 0 and 1. From the from here, from the metadata of Boston, okay, let me backtrack a bit. We see that 1 if it bounds Charles River, 0 otherwise. So notice that Chas here, this one, 0 means that the town does not bound the Charles River, and 1 if it bounds Charles River. But take a look that this is still a number. It's integer. I'm going to explain the relevance of this later on in a while. So everything is numerical. Okay, this one radius, yeah, this is radius, I think. Accessibility to index, index of accessibility 1, 2, 3, 4, 5. Okay, so it would be good to know what's the meaning of 1, 2, 3, 4, 5. So this is an index, and it's recognized here as integer. Okay, so this can be considered as a, in a while class, factor. A factor is a type of variable which can be used in order to classify your data. So for example, an example is gender, okay, male, female. That can be considered as a factor because a factor classifies your data. So for example, the year level, frosh, sophomore, junior, senior, and maybe graduating. So you have 5 levels there, and those 5 levels can be used to classify, okay, classify your data. If, for example, you have a data that's let's say residents in Metro Manila. So let's say you have Makati, Manila, etc. You have the 17 cities in Metro Manila. Then that can also be used as a factor. in order to classify your observations. Okay? So that's a factor. We'll deal with that later. And the rest are also numeric. So numeric variables, and one is integer. Okay? And as I said, this can be considered as a factor. Okay, because you are classifying whether a particular residence is bounding Charles River or not. Okay. This one also can be considered as a factor. All right. So the summary this time, let's get the summary, will give us I said 6 number summaries. No? Why 6 number summaries? You have the minimum value, okay, or this is the percentile 0, and the maximum value, percentile 100. This is the first quartile, P, which is P25, percentile 25. You have median, which is P50, and then you have third quartile, which is P75. So all the percentiles are present here. P0, I mean the most important ones. Percentile 0, percentile 25, percentile 50, percentile 75, and percentile 100, plus the mean. You have the average here. Okay, so you can see here that, okay, for chess class, if it bounds the Charles River, this, kasi this is 0 or 1, di ba? 0, which means no, 1 means yes, it bounds Charles River. So this does not have any meaning at all, class. Minimum is 0, maximum is 1, which means bounding the Charles River, and then just get the average of that. But this does not have any meaning numerically, because it's not actually a numerical variable, but a categorical or a factor. All right, although it's written as number 0 and 1. All right, so this is what the summary function gives us. And names class will give us the names of the data frame, CRIM, zone, etc. All right. Now, let's first deal with data cleaning. Before you do any statistical analysis on your data, make sure that your data is complete. Make sure that your data has no missing values, because if there are missing values, then there's a chance that your model will not run. Okay. R does that because to make you first check your data. If there are missing values, then there are many functions, like you cannot get the mean, the average of a variable, if there's a missing data. All right, so let's get the sums, column sums. Okay, so we're asking R, if there's an NA or missing value of DF, then add the sums, the column sums. How many columns do we have, class? We have 14. So this is our Boston data, 14. So what it will do is that if there are missing values here, then it will add the missing values. So let's run this class. Column sums, call sums. What are we summing? All the NA. If it's an NA, then sum the column of what? Of the data DF. Control Enter. Then we see that, okay, so all our variables are complete. No? Wala tayong missing value. Okay, we have no missing value. That's why we're okay. Our data is okay. If there are missing values, class, what do you do? What do you do? Let me first ask you, what is the last thing that you're going to do? Let's suppose this sa chess, may isang missing value dito. What are we going to do, class? We might be tempted to remove that row of observation with the missing value. Actually, that's the last thing that you should do. Okay, for example, sa CRIM, okay, let's say may isang missing value. What do you do with that, class? Again, the last thing that you have to do, that you should do, is to remove that row observation. Unless, class, for that data, let's say, for that data, all the elements in the row, for example, this number 1, NA, NA, NA. All of these are NA class. The first observation. In that case, then you can just delete that because all have NAs. If there's no NA, if there's only one NA class, the last thing that you have to do is to remove the data. So we do what we call a process of imputation. Imputation class. So what's imputation? Depending on the nature of the data class. If it's a cross-sectional data, let's say for example, there's a missing value here, NA. No, let's say for purposes of discussion, let's say the one conducting the survey erroneously missed out this data. So do we then delete observation number 5? No, that's the last thing that we should do. You can do what we call the process of imputation. The process of imputation will find a substitute for this. And one substitute for this one can be to get the average of all the other observations and replace this NA with the average. Okay? Or you can also get the median or average, so that you replace this missing value with the average or the missing value. Okay, that way you're able to preserve your data. So that's one way. There are many other ways, class, to do imputation. For now, class, we don't need that because we don't have any missing values. Okay, there are different rules, class, for time series. Iba naman yung rules for time series. All right, so let me just print this. Cat, if you remember, means concatenate, no? So this will print this text string, okay, with the colon, and then this one, /n, means this is the end. And then anything you're going to write should be on the next line. And then here I'm printing this one. So if I run this class, if I run this too, it will just give the heading or the text number of missing values, and then this one. So this is good for your write-up class in your case studies when you're using RMD. Okay, instead of just printing this one and then typing the number of missing values, you can put it here, class, cut. Okay, so that this will appear automatically. Okay, all right. Now, I said, class, that there are variables that can be considered as factor. A factor, as I said, is a variable that is used for classification. The chess data, the chess variable, class, here, 0 or 1, class, it's used to classify this, for example, this property here, property number 1. So this means that this property does not bound the Charles River. So any property that has a 1, there are ones here, no? Maybe a few. Okay. They are the properties that bound the Charles River. Okay, so what do we do, class? What we can do is to convert it into a factor. So to convert it into a factor, here, DF $chas, right? So we're telling we are creating now DF $chas, but chas is existing already, so it will change whatever is inside chas. And then we can use this as that factor, and then DF $chas. Okay, so let's see what happens, class. Let's run this, and then run again the structure. Okay, go back here, run structure, and see what happens. Okay, so if we run this, class, as that factor, Control Enter. Okay, it run. And then if I check the structure here, structure of DF, let me see. All right, there. So you can now see that the chas variable is no longer integer. It's no longer numeric. Rather, it has been treated as a categorical, in particular, a factor. Okay, factor, which means that it's used as a classifier with two levels. Okay, 0 and 1. 0 and 1. Okay, if we want, we can change the 0 and 1 because it's not instructive, so it's quite difficult uh, to recall what's 0, what's 1. Maybe what we can do is to replace 0 with no, okay, or not bound, okay. Okay, but let's just use no, which means that it does not bound. It does not bound the Charles River. So how do we change that class? Here, okay, we can use what we call levels. Okay, so we use this function levels df dollar $chas. And what will happen is that we will we will change class the levels of the variable chas with no and yes. Now take note in the structure here, what appears first is, let me run this again. What appears first is 0. So the order is very important, class. 0 and then 1. Okay, 0 and then 1. So what we're going to do is we're going to replace it with no and yes. All right, so once we run this class, run it, and then if I get the structure again, structure of df, enter. All right, note class that chas has now been, we converted it into factor a while ago, and now you can see here that there are two levels, no and yes. Okay, no and yes. A while ago it was 0 and 1. Okay, let me pause for a while and give you a few minutes, a few seconds to catch up. Maybe I'm going too fast. Uh, I will appreciate you telling me, class, if I'm going too fast. Okay, and once you're done with this, once you have confirmed that now chas has been converted into, instead of 0 and 1, no or yes na siya. And you can verify that by checking the structure, str. Okay, I'll wait for your confirmation, class, with a yes or clear if you were able to uh, do this, class. Okay, good. Thank you, Jerlane. Let's wait for the others. Chard, thank you. John, thank you. Okay, good, good. All right, so I hope that's clear, class. Uh, when you have uh, when you have variables that are when you check the structure and then they're considered as numerical, like 0 or 1, and then they can be considered, they should be considered as factors, then you can replace it, class. You can replace the leveling. Okay, so you can use the levels function. Okay, levels df dollar $chas. This is from stats package, so we didn't need to install another package for this. And then we identified it as no or yes. Okay, let's take a look, class, at the distribution. We can use the table function, table df $chas, and determine how many are no, how many are yes. Okay, there. All right, so we have this distribution. So out of the 506 observations, there are 471, class, that are that are that do not bound the Charles River, and 35 of the houses in consideration bound the Charles River. So that's the table function. Okay, let me see, class, if I can recall it. Let me create an object called T1, and then that's table.df chess. Okay, so I'm creating this table. Okay, so I have now T1, class. What's T1? T1 is, Not here. Why not here? Control Enter. Sorry. Mistake class. I'm creating this object T1. Okay, and then if I here value siya, no, it's a table. Now let's see. Prop here, prop.table T1. Okay, let's see if I remember the code for this one. Prop.table. All right, good. Okay, so instead of the the number of observations, okay, which we used here class, diba? I'm going to run both. All right. So there are 471 houses that are not bounding the Charles River and 35 that bound it, which accounts for 93% and around 6.9%. Maybe we can put here round, and 2 decimal places. The round function class will change the decimal place. Will limit the decimal place depending on what you write here too. Okay, once again, I'll run this. Control Enter. Okay, there you go. So 93% of our observations do not bound the Charles River, and 7% bound the Charles River. So if you're looking at frequency distribution, you can use the actual value, and also you can use the percentage. All right. Okay, again, pause. I'll pause for a while, class, and ask for your feedback if you're getting that. Any questions? Clarifications? Okay, good. Yeah, thank you. Okay, good. All right. Thank you so much, class. Although konti lang din pa yung nag-ano. Sige, let's give your classmates a few more seconds to, maybe I'm going too fast to follow along. Okay. All right. So thank you so much. Okay, so let's continue. Okay, I'll discuss this later. No? Dito muna tayo, class. I'll discuss the releveling. Okay, there's a kasi kanina class yung no and yes natin. We can change the order, yes and no. Okay, you might say, what's the difference by changing the order, no and yes versus yes and no? We will appreciate that when after we do after we have our first linear model. So I'll suspend the discussion of this one, releveling. Okay, let's go here, class. Now, for the age class, okay, this is an example where yung age kasi class, no? Ang sabi dito, the age is proportion of owner-occupied units built prior to 1940. Okay, proportion of owner-equipped units. Okay, which means that how many percent were built prior to 1940. Okay, sometimes you might not be interested in the proportion. So to illustrate an example where a proportion like this can be converted into a factor class. So how do you do that? Suppose yung age class, you would want to just make it, let's say, if the proportion is 50% or less, okay, then group it as 1. If the proportion is 50% or more, then group it in another one. So we're going to convert it into categorical variables, technically factors. So how do we do that, class? So I deliberately did this so that you know that if possible, if you can convert a quantitative variable like this into a categorical variable, this is what you do. So take a look at this, class. So I'm now creating an object df age group. Notice this is not class, this is not the age variable, okay? So here, df $age group. What this does is you create a new variable, age underscore group. And then take a look. We use the cat, okay, cat function to bin your data, to break your data. So here, I have 3 values here, which means that I'm breaking my data into 2. So how does that go? The first one is from negative infinity to below 50 and below, to below 50, then that will be one group. And we will call it new, okay? New. So this is the age that's less than 50 years old, okay? And then the next one is old. The next one is old class. Okay, and that's from 50 up to 50 and above. So take a look at this code class. We're creating a new variable called age group, and we're using the function cut. What are we going to cut? Si age daw. Saan natin i-break siya class? Okay? Concatenate natin negative infinity to 50, that will be one group. 50 to infinity, that will be another group. And then we identify the labels. Ang labels natin is yung below 50 class, yung proportion of 50, yung prior to 1940, sorry, proportion pala, no? That will be your new, and those above 50 will be your old. Okay? So if we run this class, I'm going to run this. Okay, and then I look at the, well, Boston. Okay. I'll just view DF class kasi yun ang ginagamit natin. Okay, DF here. Okay, so age is still here, but you can now see that a new age group is created. Old, new, old, new. If you take a look at age, 65.2. Okay, this is old. Okay, ito naman 6 points, itong house na to 45.8, so new siya. Okay, so all those that are 50 and below, new siya. Above 50, like 94.3 here, it's old. Okay, so that's how you create a grouping if you want to group a particular variable. All right, of course you can increase the breaks, no? Negative, kunyari, negative infinity to 40, then 40 to 50, and then 50 to infinity. You can do that and then create three labels for that. New, intermediate, old, you can do that. Okay, but we will not do that here. So this was meant to help you create factors, okay? Factors based on quantitative variables. You can create bins or groupings here, class. All right, so let's now go to summary statistics. Okay, so we saw that our data is clean, wala siyang missing value. Then we have converted class yung dapat natin i-convert si chas from integer to factor. Okay, si df, tingnan ulit natin class yung structure. Let's see. Structure, df. Let's double check. And you can see now that age group is a factor class. Yan, new, old. Automatic nag-factor siya class kasi, di ba? Binigyan natin ng labels, no? New and old. Okay, age is still there, still numeric. All right, so this one, summary statistics class, we can just use the summary function, no? So, concatenate natin, beginning and end, yung /n, begin dito, end dito. Summary statistics for numerical variables. Okay? Tingnan nyo to class. Ipiprint natin yung summary ng DF natin. Okay? Brackets dito class, di ba? Which means that sa subset natin, ito class, all the rows, and then ito, all the columns. Ano yung all the columns? Okay? I-apply natin class sa DF yung pag numeric siya. So what does this mean, class? It will only create the summary class, summary, for all the variables in DF that are numeric. So all the variables like si chas class, kasi factor na siya eh. Si age group, factor na siya. Hindi siya mag-recreate ng, ng summary. Why? Kasi it does not make sense to create a 6-number summary for categorical variables. No meaning, class. Okay, so run ko to, class. Control Enter. All right. So you can now see that only those numerical variables nag-create siya ng ng 6-number summary. Wala dito si chas, okay? Wala si age group. Okay. As we go along, class, we'll learn also other descriptive statistics aside from the summary. Si summary yung pinaka-simple, no? Maraming pang iba. Okay, ito naman, class, tingnan natin. Again, concatenate. Again, when we say concatenate, ipiprint niya to, no? Frequency of categorical variables. /n, yung beginning, /n means end ng text na yan. Yung susunod na ipiprint na dapat next line na. So ito, class, print table. Siguro ilagay natin, class, di ba nag-create na tayong T1, class? T1 for yung table natin for chas. Mag-create din tayo, class, ng here. Mag-create na lang ako dito, class, ng another table 2. So wait, table muna, table. Tingnan natin, class, ilan yung DF dollar. I'm now creating the frequency distribution of age group. There you go. Okay. I'm going to create an object called T2. And then just like what we did a while ago, we can get the proportion, that table of T2. Okay. So, Control Enter. I-round natin. Sige, mamaya natin i-round. 29% yung new. So, karamihan ng mga lots, class, no? Karamihan, they're old. 50 years or more. So, dito, class, what we can do here is print yung table. Actually, pwede na natin lagyan itong print T1, no? Okay, but anyway, and then print also ayun natin to, class. Control C, Control V. Proportion of si chas categorical variable, no? Ay, hindi pa pwede itong inside the hindi pa pwede sa cap. Chas categorical variable, frequency of, okay, sorry, class, binabago ko itong ginagawa ko. Okay, here I'm going to print si frequency ni chas categorical variable at saka yung proportion niya. So I'm going to actually kahit na lang dito, no? Proportion table T1. Yan. Okay, kasi mare-recognize naman ni RCT1 eh. Okay, if I print this, class, Control Enter, and tignan yung print out niya, no? Frequency of chas categorical variable 471, proportion. Okay, linagyan lang na ng text, class. Round natin, round, para dalawang decimal places lang. Yan. Once again, run this. Okay, so you can use this when you're printing, class. When you're printing text with outputs sa R Markdown nyo. Yan. Okay, maayos yung pagkasulat. And this one, class, we're going to, okay, copy this, Control C, Control V. Ito naman si age group. Age underscore group. Categorical variable. Dapat lang S. Proportion of age underscore group. And this one should be T2. Nag-create na tayo ng T2 class, no? Kanina. Alright? So, if I print this class, sabay ito. There. Frequency ni Chas at saka proportion niya. Frequency ni age group. Oh, wait. Sorry, mali. Dapat to. Hindi ko napalitan to. Okay. There you go. Control Enter. Yan. So si Chas, 93% yung no. Si ano naman, si age group, okay, 29% lang yung new. Okay, class? Sige, I'll give you time to work on that. When you're done, class, kindly chat so that I know when to continue. Waiting for your response, class, huh? If you're okay, if you're able to follow. So, combination siya ng ano, ng printing ng ano ng heading nyo sa isang output. You can use the cat function. And then sa ilalim yung output na gusto nyong ipalabas. I hope everybody was able to follow, class, just a simple code of the text and then the output. Now for the last one, we can create now. This is the same as the S supply a while ago. Okay, but this time the function is correlation, and we would like R to generate a correlation matrix of the DF data set, and only for those that are numeric class, and then round natin to decimal places. Let's see what happens. So what it will do is it will get the correlation of cream and zone, cream and industry, etc. Those that are numeric. For the numeric variables, you can get the core. For example, class. Now let me just illustrate that. Let's get the correlation. Use the core function of cream and df under let's say indus. Okay, so this is the correlation. From your basic stat class, you know that correlation gives us the direction and the strength of the relationship between two variables. Control Enter. There, it's 0.4. So it's medium yung ano yung their medium yung correlation nila, no? Okay, so let's create that now for the whole data set for the numeric variables. And how do you do that? Okay, we apply the core function for the df. Okay, all the rows and the columns, only those that are numeric and 2 decimal places. So if you run this, I think I'm going to share this with you, Control C, to save on time. Okay, and then let's run this, Control Enter. Again, Control Enter. There. Okay, so you have here the correlation matrix. Let me increase first the size of this. Oops, Control Z. There. Okay. So you have the correlation between cream and cream. Of course, there it's 100% since you're getting the correlation of the same variable. The diagonals here, class, if you take note, are all one. Okay. They're all one because you're getting the correlation of the, let's say, medium value with medium value. Of course, that will be 100% because they're perfectly the same. Okay. But for the others, correlation between cream and industry, 0.41, that's what we got a while ago, right? 0.41. Here, 0.41. Okay. Here. Okay. So, okay, correlation matrix for the numerical variables. There. So when you need this class, ito yung lalabas. Okay. So why is this important, class? Now, the dependent variable that we're going to use is median value. Okay. And the the other predictors here, the numerical predictors are all the other variables. Okay. If you take a look at the median value, okay. So for example, for how is it related with cream? It's negative correlation, which means that when cream goes up, median value goes down. So they go in opposite directions, and the correlation is negative 0.39. Okay, here number of rooms is 0.7. Okay, zero point 0.7 here. So it's positive. What does that tell us? That the number of rooms is positively correlated with the median value, which is logical. The more rooms, class, the higher will be the value of the house, zero point 0.7. And what are another one is this one, class? What's L stat? I forgot what's L stat, but it's negatively correlated and it's a high correlation also. Okay. All right. So this is the correlation function, class. There are other ways to do this, but we will discuss them later on. We're just practicing first the use of sapply, okay? Applying the correlation function to to your column, class, to your columns, to those that are numeric, class. Okay, round is for the 2 decimal places. Okay, so let's now, class, create our first regression model. Okay, so here, let me explain to you. Uh, let's get the names again of DF. Okay. So I'm going to create now. Let's now create the full model where the dependent variable is the median value of the house. Okay, and the rest are your predictors. Now, to write that class, let me just, let's write this class full model. Let's just call it full model 1, alt minus. We use the LM function here. LM stands for linear model. And then we have to identify what your dependent variable is. Okay, median value of the house. Okay, and then the tilde class, shift on the upper right, your upper right class. This is the tilde. And then you identify your predictors. So it depends on what you're modeling. For us, we're going to create the full model. So all the predictors are this one, except for the median value. So I'll just copy this, Control C. Okay. Maybe put it here first. See, let me just create a what's black? Wala naman. Meron. I'm going to remove this. What am I doing, class? I'm just copying the predictors because I'm going to show you how this is done. And then Control F, and then quotes. In the selection, replace all. Okay. So tinanggal ko lang class yung quotes kasi I'm going to copy this here. Control C, and then Control V. Okay. Okay. So take a look, class, what I'm doing. I'm identifying my variables. So si crime, si zone, si industry, plus si Charles River, plus si Knox, plus si room, plus si age, plus si distance, plus si radius, plus si tax, plus ratio, plus black, plus Elstat, plus age group, okay, comma, data is equal to DF. Okay. I'll share this with you, class, so that you don't have to write it. Control C. All right, there. And then I'm going to delete this. Okay, take a look at this, class. How do we create a regression model in R? So I'm giving it a name, full model 1. And then we use the function LM, which stands for linear model. And then you start first with your dependent variable, and then tilde associated with, okay, associated with, then your independent variables. So our independent variables are cream, zone, industry. I chose all, class, all the independent variables in our DF data set. Of course, except MED-V, because median value is the dependent variable. And then you have to identify what data. Their data is DF. All right, before we run this, class, may I seek your comment, class, yes or no, if you were able to follow. Okay, thank you. And good. All right, very good. So I hope the others are able to follow. No? Okay, now take a look at this, class. This is an alternative. Okay, LM, medium value, tilde, dot. Now what does this dot mean? That means all the other variables. which is this one, which is this one. Okay. But for me, I prefer to write the whole. Okay. The whole independent variables. Okay. But if you're in a hurry, just want to know the model, then you can just use this dot. The dot here means all the variables. Okay. And the same class data is equal to data is equal to df. So let's run this first. I'm going to go here to this anywhere here in this code chunk portion here, and then control enter. All right, control enter. Then let's see class. Let's see full model one. Full model one class is a list. It's a list. Full model one. It's a list of 13. Let's check what's inside here. Okay, so this is full model one. Yeah, class. It tells us what's inside full model one. Yeah, it's a list of 13. You have the coefficients here, class. If I click this, so these are the coefficients. These are your betas. Yeah, these are your betas. Okay. And then you have your residuals, di ba? Ito yung epsilon natin. Okay. Each observation class, observation number 1, has a residual. Kasi meron kang sa observation number 1, you have your actual value, this one, asan si med v. This is your actual value. And then you have your predicted value, yung y hat natin. Okay. And then the difference between them is your residual. So your LM output includes the residual class. Asan na ito class? Includes the residual. There. And it also includes other class. Fitted values to. Yan. Fitted values class. What's the fitted value? This is your predicted value. Okay. So, tingnan natin here. Our actual value is 24. No? For this house number 1, the median value is 24. The predicted value based on our model is 29.69. Okay. Actual value 24. Predicted value 29.69. So your residual is your actual value 24 minus 29.69. So that's around negative 5, no? If you take a look at the residuals here, yeah, negative 5.69. Yan. Okay, so kompleto tong residuals nito. Lahat ng observations may residuals. All the observations have, of course, their predicted value. Okay, so my predicted value, my fitted value, okay, my predicted value. Okay, and then we're going to look at the other elements in the future. Okay, let's go back to our model. So you can access this class by, you can print the model by summary. Okay, summary full underscore model 1. So this is how you print the results of the model. Control enter. Okay, there you go, class. Okay, so this is the result of our first regression model. Okay, now what's important is that we have to understand all of this. Okay, for example, what's the meaning of cream here? You have to interpret it in the light of the metadata. Ano ba yung cream class? Cream is per capita crime rate by town. Okay? Okay, so what does this mean? What does this mean, class? You're going to interpret this in relation to your dependent variable. So, on the average, okay, please take note of what I'm saying. On the average, the median, every 1 per capita increase, okay? Notice what I said. 1 unit per capita crime rate, 1 unit increase in per capita crime rate will result into the what? The reduction, kasi negative class. Reduction of 0.109902 in the median value of your house. Okay? Then ceteris paribus. Okay, notice I said ceteris paribus, which means all things being the same. Which means that you're only changing cream by 1 unit. The others remain the same. You're not changing them. Let me repeat, class. On the average, a one unit increase in the per capita crime rate, ito yung cream natin, class. Per 1 unit increase in per capita crime rate will result into a 0.11, just round it off, decrease in the median value of the house. Okay, ceteris paribus. I said ceteris paribus, class, ceteris paribus. Okay, which means all things being equal, all things being the same. Why did I say that? Kasi sinabi ko, di ba, pag nag-increase si crime rate ng isa, class, si median volume, magbabagsak ng 0.11. Okay? Ang mag-i-increase lang si crime rate, ha? Hindi si zone, hindi si index. Okay? This value class is the marginal effect of crime on median value, all things being equal. So for example, tingnan natin tong NOx class, ito. Ang laki ng effect, no? By the way, class, 3 stars siya. Ano ibig sabihin 3 stars? Take a look at this, class. Significant siya at, okay, pag 3 stars, class, significant at 0.001. And that's what that means. So this is highly significant. No? Significant at 0.1%. Pag 2 stars, significant at 1%. Pag 1 star, significant at yung 5%. Ito yung usual, no? Ito yung confidence significance level na usually ginagamit. Pag dot, 1 dot lang, class, ito, it means significant at 10%. Usually, ang benchmark natin, class, ito. Okay? And then, none, no? 1. All right, so all those variables here with the asterisk are all statistically significant. Okay, statistically significant sila, class. Okay, now let's take a look at this one, class. Just yes. Significant siya at 1%. So what's the meaning of this, class? Okay, take note, class, take note that just is a factor. Bakit nagka-just yes dito? Okay, let me explain, class. So please pay attention to this one, class. If we take a look at DF, class, si just, ito, no? Ano yung levels ni just? No or yes lang naman, di ba? No or yes. So between the two, no at saka yes. Between the two, which level will appear first alphabetically? So si no, di ba? Kasi alphabetically mauuna siya. It doesn't matter, class, kunyari yes to, hindi natin tinatanong kung sino yung unang nag-a-appear sa data. Ang tanong natin, sino yung alphabetically mauuna? Okay? Si no. What does that mean, class? No will be your benchmark. Benchmark or your reference. Reference level siya. Ano ibig sabihin ng reference level? Ang ibig sabihin niyan, class, the model that is being generated is being benchmarked with yung no na value. Okay, let me clarify that, no? So itong value na to, class, ito, chas. Take note, no? Chas yes. Bakit siya naglagay ng yes? Ibig sabihin ng class, yes is not the benchmark, no? Ang benchmark natin dito, si no. Bakit si no? Kasi by default, kung sino mag-a-appear na alphabetically first, siya yung gagawing benchmark. Okay, now how do you interpret this? How do you interpret this now? On the average, okay, on the average, houses that bound the Charles River, okay, has a 2.69 or 2.7, whatever this is, dollars yata in ano ba yung median value? The median value is, ito, no? Thousands, no? Houses that bound Charles River costs $2.7 thousand more than houses that do not bound Charles River, ceteris paribus. Again, class, when you interpret this factor na to, yung chassis na to should be interpreted with reference to the benchmark. Sino yung benchmark natin? Si no. Sino si no? Ito yung no, yung mga houses na does not bound the Charles River. So once again, how do you interpret this? On the average, houses that bound Charles River, yes, no, are $2.7 thousand more expensive. Bakit more expensive? Kasi positive to class. If this was negative, ang interpretation natin dyan will be cheaper, no? Kasi negative siya, or less expensive, no? Than, okay, balik ako sa ano ka, houses that bound the Charles River costs more, okay, by $2.7 thousand than their counterparts. Ano yung counterparts nila? Houses that are not that do not bound Charles River. So yan ang interpretation yan, class. So that's very important, no? Kaya nga, class, importante yung mga factors. When you interpret factors, it would be always interpreted in the light of the benchmark. Okay, how about this, class? Ito. Kino yung class? New or old yan di ba? New or old? New, old. Sino mauuna, class? New. Tapos yung isa, old. So alphabetically, class, sino mauuna? Ang mauuna, si new. Okay? So si new will be the benchmark class or the reference. Okay? So when you run the regression, class, ang lalabas dito, old. Yan, no? Old. So what does that mean? When you interpret this, interpret it in relation to the benchmark, which is new. So how do we interpret this? On the average, houses that are ano yung old, yung 50 years, ba? 50 years older, okay, are priced $1.03 thousand less class than houses that are 50 years up to 50 years old. Okay? So in-interpret natin to ngayong class na in relation to yung newer houses. But take note, class, it's not statistically significant, no? Walang laman dito, ibig sabihin hindi siya statistically significant. Only those variables that have asterisk here. Ito, significant at 1%. Pag isang star lang, class, significant at 5%. So that's how, class, you will interpret all of this. No? Yung mga yan. So for example, ito, class, on the average, areas that have on the average an increase, ano ba yung NOx natin dito? Okay. Yan. An increase of 1 ppm, parts per million, in NOx concentration will lead to an 18,000 reduction. 18,000 reduction, class. Di ba ang median value natin, thousands of dollars? 18,000 reduction in the median value pricing of the house. Okay? So the poisoner, the more poisonous the area is, the cheaper will be the house. Of course, no? Very logical yan. Ito number of rooms, class. Oh? On the average, okay, a 1 unit increase. Lagi yung tinitingnan 1 unit, no? 1 unit increase in the number of rooms, no, per house yields to a 3.8 increase in the median value of the house. Ceteris paribus. Always put ceteris paribus. And then class here, it's statistically significant at very highly statistically significant at 0.1. Okay? All right, it's almost time, class. So next meeting, we're going to continue with this, class. Okay, we're going to continue with this, and it's very important that you should know how to know how to interpret this one and create the equation. Kasi so median value ng house is equal to all of this, yung mga significant variables. And lastly, class, ano ibig sabihin ng intercept? Okay, the intercept, class, is the value of the median value of your house. Okay, average value of the median value, average median value of the house, class, if all the variables are equal to 0. So, kasi kung 0 lahat to, class, kung 0 lahat, mawawala to, di ba? Ang matitira lang yung intercept. And the intercept is the value, the average median value of the house. Okay. So, next meeting, we're going to continue with this, class. Kindly bring your laptops when we meet face-to-face next meeting. Okay. So let me now stop recording.